The first thing Gefreiter Franz Richter noticed as the Liberty ship SS Thomas Marshall approached New York Harbor on June 15, 1943, wasn't the Statue of Liberty or the towering skyline of Manhattan. It was the endless parade of cargo vessels streaming in and out of the harbor, their holds bulging with materials he had never seen in such quantities. Richter, a veteran of Rommel's 21st Panzer Division captured at Tunisia, pressed his face against the salt-stained porthole and counted. One ship every 3 minutes. Then he stopped counting because the numbers made no sense. "Mein Gott," whispered Feldwebel Werner Schmidt, crammed into the bunk beside him. Schmidt had commanded a Tiger tank crew until American artillery had turned his massive 68-ton machine into scrap metal outside Kasserine Pass. Now he stared through the same porthole, watching America's merchant fleet move like clockwork through the harbor. How many ships do they have? The answer would have broken what remained of their morale. The United States Maritime Commission had produced 5,777 merchant vessels during the war, while German U-boats had managed to sink approximately 3,500 Allied ships total. America was building ships faster than Germany could sink them. But Richter and Schmidt didn't know these numbers yet. They would learn them soon enough. The journey from North Africa to New York aboard the Thomas Marshall had taken 18 days. 18 days of watching American efficiency operate with mechanical precision. The ship's crew served meals with the same rations provided to American soldiers: roast beef, fresh vegetables, white bread, and coffee that actually tasted like coffee rather than the acorn substitute German troops had endured for 2 years. Lieutenant Friedrich Weber, a U-boat officer whose submarine had been depth-charged into surrender off Gibraltar, kept a mental inventory of everything he consumed. "They feed prisoners better than we fed our own troops," he confided to his diary, written on American paper with an American pencil. But the food was only the beginning of their education. As the Thomas Marshall docked at Pier 92 in Manhattan, Richter watched stevedores unload cargo with the precision of a military operation. Crates labeled Lend-Lease moved in an endless stream toward waiting freight cars. Cases of ammunition, boxes of medical supplies, barrels of aviation fuel, and machinery Richter couldn't identify. The dock workers, he noticed, weren't soldiers. They were civilians, many of them women, handling equipment that would have required military engineers in Germany. "How do they have so many people working?" Schmidt asked an American guard who spoke broken German. The guard, a corporal from Wisconsin whose grandfather had emigrated from Bavaria, looked confused by the question. "People working? This is just one dock. We got hundreds like this from Boston to San Francisco. My sister works at Willow Run making B-24 bombers. They roll one off the line every 63 minutes, 24 hours a day." Schmidt translated this for Richter, but the numbers sounded like propaganda. Every 63 minutes? Impossible. A single bomber required thousands of parts, precision assembly, testing. The Junkers factory in Dessau took weeks to complete a Ju-88, and that was when they had materials. The train journey from New York to Camp Gruber in Oklahoma stretched across 1,900 miles of American landscape that redefined their understanding of industrial capacity. Unteroffizier Klaus Hartmann, an infantry veteran from the Gothic Line in Italy, spent the entire journey with his face pressed to the Pullman car window. The luxury of the prisoner transport train shocked him more than his capture. Cushioned seats, clean restrooms, dining cars serving hot meals. German troop trains were cattle cars compared to this. But it wasn't the comfort that broke his spirit. It was the factories. Mile after mile, hour after hour, the train passed industrial complexes that dwarfed anything in the Ruhr Valley. In Pennsylvania, the Bethlehem Steel Works stretched for miles along the horizon, its blast furnaces glowing like earthbound stars. Smokestacks rose in formations that reminded Hartmann of artillery batteries, except these weren't weapons of destruction. They were weapons of production. "How many workers?" he asked the American guard, pointing toward a factory complex that seemed to have no end. "That's just one plant," the guard replied. "Bethlehem's got facilities in 16 states. They produce more steel in a month than Germany produces in 6 months." This statement, which sounded like American boasting, was actually conservative. By 1943, American steel production reached 89 million tons annually, compared to Germany's 34 million tons. The German prisoners were witnessing the industrial machine that would produce two-thirds of all Allied military equipment by 1944. In Chicago, the train stopped for refueling, and the German prisoners were allowed to stretch their legs under guard supervision. Richter found himself standing on the platform of Union Station, watching a parade of freight trains loaded with military equipment heading west. Tank after tank, artillery piece after artillery piece, truck after truck. He began counting again, then stopped when he reached 500 tanks on a single train. "Where are they going?" he asked. "Pacific Theater," the guard replied. "We're fighting two wars, you know, Europe and the Pacific. Same time." This casual statement revealed the scope of American capability that German intelligence had completely failed to grasp. Germany struggled to maintain adequate supplies on a single front. America was simultaneously supplying forces in Europe, the Pacific, and providing lend-lease materials to Britain and the Soviet Union. The logistics alone should have been impossible. But the evidence rolled past their eyes on rail cars stretching to the horizon. Sergeant Giuseppe Rossi of the Italian Bersaglieri had been captured during Operation Torch in North Africa and shipped to America aboard the same convoy system that brought the German prisoners. His perspective differed from his German allies because Italy had already surrendered by the time he reached American shores in September 1943. Rossi found himself classified not as an enemy prisoner but as a potential ally, eligible for the Italian Service Units program that would eventually enroll 45,000 of the 51,000 Italian POWs in America. Rossi's first assignment took him to the Ford Motor Company's River Rouge complex in Michigan, where he worked alongside American civilians producing military vehicles. The scale of the operation redefined his understanding of mass production. The River Rouge plant employed 120,000 workers and consumed raw materials at rates that seemed physically impossible. Every day, 100 tons of steel, 1,000 tons of coal, and 3 million gallons of water flowed through the facility. In Italy, Rossi wrote to his family, "We have factories, but this is not a factory. This is a city that manufactures cars and trucks like a farm grows wheat." His Italian perspective proved particularly valuable because Italy had been considered an industrial power in Europe. Fiat, Breda, and Ansaldo were respected manufacturers. But Rossi's first week at River Rouge taught him that Italian industrial capacity was essentially medieval compared to American methods. The assembly line system, perfected by Ford in the 1920s, had evolved into something that approached industrial magic. Parts arrived at precisely the right moment. Workers performed specialized tasks with mechanical precision, and completed vehicles rolled off the line in an endless stream. "We make mistakes when we think of America as a rich country," Rossi observed in his diary. "America is not rich. America is efficient. They waste nothing and produce everything." This efficiency extended beyond the factory floor into every aspect of American war production. Caporale Marco Bianchi, an Italian alpine trooper who had fought in the mountains of Yugoslavia, found himself assigned to work at the Consolidated Aircraft Corporation plant in San Diego, California. His job involved installing hydraulic systems in B-24 Liberator bombers, the same aircraft that had bombed his positions in Italy. The irony wasn't lost on him, but the scale of production overwhelmed any personal resentment. Consolidated San Diego plant produced B-24s at a rate of 150 aircraft per month at peak production. The facility employed 41,000 workers operating in 3 shifts around the clock. Bianchi's shift ran from midnight to 8 in the morning, and during those 8 hours, he watched 3 complete bombers roll out of the assembly building. Each bomber has 1,550,000 parts, his American supervisor explained. "We keep track of every bolt, every wire, every rivet. Nothing gets lost, nothing gets wasted." German industrial methods, which had seemed sophisticated and systematic, appeared primitive in comparison. The Germans built excellent individual machines, but they had never mastered mass production on the American scale. When Bianchi examined a B-24's construction, he found that many components were interchangeable across different aircraft types. American manufacturers had standardized parts production to achieve economies of scale impossible under the German system of specialized, craft-oriented manufacturing. This standardization extended to weapons production with results that staggered the Axis prisoners. Tenente Antonio Ferrari, an Italian artillery officer who had operated 75mm guns on the Gustav Line, found himself assigned to work at the Lake City Army ammunition plant in Missouri. The facility existed for one purpose: manufacturing small arms ammunition at rates that defied conventional logistics. Lake City's production numbers read like fantasy. The plant produced 6 billion rounds of small arms ammunition during the war years, employing 41,000 workers at peak capacity. Ferrari's job involved quality control inspection of 30-06 rifle cartridges. In a single 8-hour shift, he examined 20,000 rounds of ammunition. 20,000 rounds represented more ammunition than his entire Italian artillery battery had fired during 6 months of combat. The Americans don't fight a war, Ferrari concluded. They operate a war like a business. Every bullet, every shell, every bomb is manufactured with the same precision they use to make automobiles or radios. The comparison to radios proved more significant than Ferrari realized. American electronics manufacturing had achieved mass production capabilities that completely outclassed European efforts. Sergeant Hiroshi Tanaka, one of the few Japanese prisoners of war held in American facilities, experienced this firsthand when assigned to work at a Zenith Radio Corporation plant in Chicago. Tanaka had been captured during the American invasion of Saipan in June 1944, one of only 37 Japanese soldiers who surrendered rather than die in the final banzai charge. His cultural shame at survival was compounded by his assignment to manufacture radar equipment for American warships and aircraft. The same technology he was helping to build had detected his unit's positions and guided the naval gunfire that destroyed his regiment. But his technical background as a radio operator gave him unique insight into American electronics production. The Zenith plant produced military radios, radar components, and navigation equipment at scales that Japanese industry couldn't match even in peacetime. During his first week, Tanaka watched the assembly of 1,000 military radios. In Japan, a similar facility would have produced perhaps 50 radios in the same time frame. American manufacturing is like their country, he wrote in his diary, maintained secretly in violation of Japanese military doctrine that prohibited surrender and collaboration. Everything is big. Everything is fast. Everything works. The Japanese cultural context made Tanaka's observations particularly valuable because Japanese industry had been specifically designed to compete with American manufacturing. Japanese planners had studied American methods, imported American machinery, and attempted to replicate American techniques. But working inside an American factory revealed the fundamental differences that made Japanese industry ultimately incapable of sustaining a long war against the United States. American workers, Tanaka observed, were not simply following orders. They understood their role in the production process and frequently suggested improvements. The factory floor operated as a collaborative system where individual expertise contributed to collective efficiency. This contrasted sharply with the rigid hierarchical system in Japanese factories, where workers were expected to follow instructions without question or innovation. More significantly, American industry was fully integrated with scientific research and development. The Zenith plant received regular updates and improvements from university laboratories, private research facilities, and military technical centers. New designs, better materials, and improved manufacturing techniques flowed continuously from research to production. Japanese industry, while technically sophisticated, operated in isolation from such systematic innovation networks. But the most crushing realization for all the Axis prisoners was the scale of American production compared to their home country's capabilities. Franz Richter, the German tanker who had first glimpsed American efficiency in New York Harbor, spent 6 months at Camp Gruber in Oklahoma before being assigned to agricultural work in Kansas. His assignment placed him on a wheat farm owned by the Clausen family, Mennonites whose pacifist beliefs led them to treat their German workers with remarkable kindness. The Clausen farm operated with the same efficiency principles that governed American war production. Modern machinery, scientific farming methods, and systematic logistics produced wheat yields per acre that exceeded German agricultural productivity by 40%. But it was a conversation with Jacob Clausen, the farm owner, that revealed the true scope of American capacity. Your country grows enough food to feed itself and export millions of tons overseas, Richter said one evening as they finished harvesting. How is this possible? Clausen, whose German was fluent due to his Mennonite heritage, smiled at what he considered a simple question. Franz, we feed ourselves, we feed Britain, we feed your Russian enemies, and we still have surplus. America has more farmland than Germany has total land. We have tractors where you have horses, fertilizer where you have hope, and organization where you have orders. This agricultural abundance supported the industrial machine that was grinding the Axis powers into defeat. American farms produced enough food to maintain full employment in war industries without rationing that crippled German worker productivity. Agricultural efficiency freed millions of Americans for military service and war production while maintaining civilian morale through adequate nutrition. The numbers, when Richter finally learned them, were devastating. American agricultural production in 1944 included 108 million tons of corn, 66 million tons of wheat, and 37 million tons of soybeans. Germany's total grain production had fallen to 32 million tons by 1944, forcing the Nazi regime to rely on conquered territories for basic sustenance. Werner Schmidt, the former Tiger tank commander, experienced the industrial reality from a different perspective when assigned to work at the Chrysler Tank Arsenal in Detroit. The facility had been constructed specifically for tank production, transforming automotive manufacturing expertise into armored vehicle mass production. Schmidt's technical knowledge of German armor made him uniquely qualified to understand what he was witnessing. The American M4 Sherman tank, which German crews had dismissed as inferior to the Panzer Mark IV and hopelessly outmatched by the Tiger, was being produced at rates that redefined armored warfare. The Detroit Tank Arsenal produced 1,720 Sherman tanks per month at peak production. By comparison, German industry produced approximately 2,500 tanks total during 1944. They don't build better tanks, Schmidt observed in a letter to his wife that American censors allowed to pass. They build more tanks, many more tanks. When we destroyed one Sherman, 3 more appeared. We thought American tanks were inferior because we fought them one-on-one. But Americans never fight one-on-one. They fight 10 on 1 or 20 on 1 inch. Schmidt's technical assessment proved accurate. American tactical doctrine was based on quantity and logistics rather than individual superiority. Sherman tanks were designed for mass production, ease of maintenance, and rapid deployment. While German tanks were engineering marvels, they required specialized parts, extensive maintenance, and skilled crews. Sherman tanks could be repaired by automotive mechanics using standard tools and replacement parts available anywhere in the American supply system. The maintenance difference was crucial. A Tiger tank required 40 hours of maintenance for every 10 hours of operation. A Sherman required 8 hours of maintenance for every 10 hours of operation. German tankers spent more time repairing their vehicles than fighting with them. American tankers spent more time fighting than repairing. But the most significant difference was production sustainability. German tank production depended on slave labor, conquered resources, and increasingly desperate expedients as Allied bombing disrupted supply chains. American tank production was fully integrated into the domestic economy, supported by willing workers earning competitive wages, and supplied by secure internal transportation networks. Friedrich Weber, the U-boat officer who had witnessed the efficiency of American shipping in New York Harbor, gained additional perspective when assigned to work at the Newport News Shipbuilding and Drydock Company in Virginia. His submarine warfare experience gave him unique insight into American naval construction capabilities. The German U-boat fleet, which had terrorized Allied shipping during the early war years, totaled approximately 1,200 submarines constructed during the entire war. Weber watched American workers complete 4 Liberty ships per week at the single Newport News facility. Liberty ships weren't warships, but their construction demonstrated American shipbuilding capacity that completely outmatched German capabilities. "We built submarines to sink their ships," Weber wrote in his diary. "But they build ships faster than we can sink them. Much faster. And now they build escort vessels faster than we can build submarines. The escort vessel production particularly impressed Weber because American shipyards were simultaneously producing destroyers, destroyer escorts, cruisers, battleships, and aircraft carriers while maintaining the Liberty ship program. German shipyards had focused primarily on U-boat construction at the expense of surface vessel development. By 1944, the German surface fleet was essentially non-existent while American naval power dominated every ocean. Weber's technical assessment of American shipbuilding methods revealed systematic advantages that German industry couldn't match. American shipyards used modular construction techniques that allowed different sections of ships to be built simultaneously and assembled rapidly. German shipbuilding remained craft-oriented, with individual vessels constructed from start to finish in linear fashion. More significantly, American shipyards were fully integrated with the national transportation system. Raw materials flowed efficiently from steel mills, component manufacturers, and parts suppliers. German shipyards struggled with supply shortages, transportation disruptions, and raw material rationing that slowed construction and reduced quality. The aircraft production disparity provided the most shocking revelation for German prisoners assigned to aviation facilities. Klaus Hartmann, the infantry veteran who had watched American factories from the train window, found himself working at the Boeing Plant 2 facility in Seattle, Washington. His assignment involved installing electrical systems in B-17 Flying Fortress bombers, the aircraft that had destroyed German cities and industrial capacity. Boeing's Seattle facility produced B-17s at a rate of 16 aircraft per day at peak production. Hartmann worked on electrical installation for 3 months, personally contributing to the completion of over 300 bombers. Each bomber carried a crew of 10 men and enough firepower to level a small city. 300 bombers represented more striking power than the entire Luftwaffe possessed by late 1944. "The Americans build airplanes like we build bicycles," Hartmann observed to a fellow prisoner. "Fast, simple, and many at the same time." The comparison to bicycles was more accurate than metaphorical. American aircraft production had achieved the same standardization and efficiency that characterized automotive manufacturing. Parts were interchangeable between different aircraft, components were mass-produced using specialized machinery, and assembly was organized for maximum throughput. German aircraft production, while technically sophisticated, remained essentially artisanal. Each aircraft was individually crafted by skilled workers using traditional methods. Quality was often superior, but quantity was limited by the craft-based approach that couldn't scale to American levels. The statistical reality was devastating. American aircraft production during World War II totaled approximately 300,000 military aircraft of all types. German aircraft production totaled approximately 120,000 military aircraft. The United States built more aircraft in 1944 alone than Germany built during the entire war. But raw numbers only told part of the story. American aircraft were supported by a logistics system that maintained operational readiness at rates German forces couldn't match. Giuseppe Rossi, working at the Ford Willow Run plant, witnessed the production of B-24 Liberator bombers at rates that seemed physically impossible. The Willow Run facility occupied 67 acres under a single roof, making it the largest manufacturing building in the world at the time. The assembly line stretched for over 1 mile, with aircraft moving through progressive stations where specialized teams installed components with mechanical precision. At peak production, Willow Run completed 1 B-24 every 63 minutes, 24 hours per day, 7 days per week. "This is not manufacturing," Rossi wrote to his family. "This is industrial magic. They take aluminum sheets and rivet them into bombers like a magician pulls rabbits from a hat." The Willow Run production line employed 42,000 workers, many of them women who had never worked in manufacturing before the war. These Rosie the Riveters achieved productivity levels that exceeded experienced male workers in traditional aircraft plants. The combination of systematic training, specialized tools, and efficient organization overcame the supposed disadvantage of inexperienced workers. German aircraft plants, by comparison, relied on highly skilled craftsmen whose expertise couldn't be rapidly replicated. When experienced workers were killed in bombing raids or drafted for military service, German aircraft production declined because the craft-based system couldn't quickly train replacements. American mass production methods were designed to utilize semi-skilled workers who could be trained rapidly and replaced easily. Marco Bianchi, the Italian Alpine trooper working at Consolidated Aircraft in San Diego, observed additional advantages in American aircraft production that German intelligence had failed to understand. The San Diego plant operated as part of an integrated network that included engine manufacturers, electronic suppliers, armament producers, and accessory manufacturers. "They don't build airplanes," Bianchi noted in his diary. "They assemble airplanes from parts made by hundreds of different companies. Each company specializes in what it does best, and the airplane company puts everything together." This distributed manufacturing system provided resilience that German industry lacked. When Allied bombing damaged a German aircraft plant, production stopped until repairs were completed. When weather delayed shipments to an American aircraft plant, alternative suppliers provided replacement components. The American system was designed for reliability and continuity. Moreover, American aircraft production was supported by massive investments in research and development that continuously improved performance and manufacturability. The B-24 that Bianchi helped assemble in late 1944 incorporated dozens of improvements over early models, but the basic assembly process remained the same. German aircraft development, while technically advanced, frequently required complete retooling that disrupted production and delayed delivery. The engine production disparity was particularly significant because aircraft engines represented the most technically demanding aspect of aviation manufacturing. Antonio Ferrari, working at a Pratt & Whitney engine facility in Connecticut, witnessed the production of our two 800 double Wasp engines that powered American fighters and bombers. Pratt & Whitney's engine production exceeded the entire German aviation engine industry by a factor of 3 to 1. The R2 800 engine, which powered aircraft from the F-6F Hellcat fighter to the C-46 commando transport, was manufactured at rates of over 1,000 units per month. German aviation engines were produced in quantities of hundreds per month across all manufacturers combined. American engines are not necessarily better than German engines, Ferrari observed, but there are many more American engines than German engines. Many, many more. The reliability advantage was equally important. American aviation engines were designed for ease of maintenance and long operational life. German engines often produced superior performance but required constant attention from skilled mechanics. American engines could be maintained by less skilled personnel using standard tools and procedures. This maintenance advantage multiplied American numerical superiority. German aircraft spent significant time grounded for engine repairs and adjustments. American aircraft spent more time in operational status, effectively multiplying the impact of numerical advantage through higher utilization rates. The industrial infrastructure supporting American war production impressed Axis prisoners more than any single facility or production line. Hiroshi Tanaka, the Japanese radio operator working at Zenith in Chicago, gained access to American technical publications that revealed the scope of industrial integration impossible in Japanese or German systems. American industry operated as a unified network where steel mills supplied automotive plants that supplied aircraft manufacturers that supplied military forces that protected shipping that imported raw materials that supplied steel mills. The circular efficiency of this system created compound advantages that grew stronger as production increased. Japanese industry, while well organized, operated in isolation from international supply networks. Japanese steel mills depended on imported raw materials that became increasingly difficult to obtain as American submarines and aircraft disrupted shipping. Japanese manufacturers couldn't achieve American economies of scale because domestic markets were limited and export markets were controlled by military priorities. The scientific integration of American industry particularly impressed Japanese prisoners because Japan had attempted to copy American research and development methods. But Tanaka discovered that American technical superiority was based not on individual breakthroughs but on systematic collaboration between universities, government laboratories, and private industry. Americans don't invent better machines, Tanaka observed. Americans invent better ways to invent better machines. Their science serves their industry, and their industry serves their science. This symbiotic relationship produced continuous improvements in manufacturing techniques, materials science, quality control, and process optimization. German and Japanese industries relied primarily on individual genius and craft expertise. American industry systematized innovation through organized research, statistical analysis, and collaborative problem-solving. The radar technology that Tanaka helped manufacture exemplified this systematic approach to innovation. American radar development involved universities like MIT, government laboratories like the Naval Research Laboratory, and private companies like Zenith, General Electric, and Western Electric. Each organization contributed specialized expertise while sharing information through coordinated research programs. Japanese radar development, by comparison, was fragmented among competing organizations that guarded their discoveries for competitive advantage. The Japanese military services didn't share technical information with each other, let alone with civilian manufacturers. This compartmentalization prevented the synergistic breakthroughs that characterized American technology development. But the most devastating realization for Axis prisoners was the sustainability of American war production. Franz Richter, after 18 months of agricultural work in Kansas, was transferred to a General Motors facility in Detroit that had converted from automobile production to tank manufacturing. His new assignment provided perspective on American industrial flexibility that German planners had completely misunderstood. The General Motors tank plant had been producing Chevrolet automobiles in 1941. When America entered the war, the facility was rapidly converted to manufacture M4 Sherman tanks using the same assembly line techniques, many of the same workers, and much of the same equipment. The conversion required 6 months. A similar conversion in Germany would have required 2 to 3 years. Americans changed their factories like they changed their clothes, Richter observed. Fast and without much worry. This industrial flexibility provided strategic advantages that Axis planners had failed to anticipate. American industry could rapidly shift production priorities based on military requirements. German industry was locked into specialized facilities that couldn't easily adapt to changing needs. More importantly, American industrial conversion didn't reduce civilian production as dramatically as German mobilization. American automobile production fell from 4 million cars in 1941 to 139 cars in 1943, but civilian goods production continued at levels sufficient to maintain morale and productivity. German civilian production virtually stopped, creating shortages that reduced worker efficiency and undermined home front support. Werner Schmidt, after completing his assignment at the Chrysler Tank Arsenal, was transferred to work at a Ford facility producing aircraft engines. The transition from tanks to aircraft engines illustrated American manufacturing versatility that German industry couldn't match. Ford's aviation engine production utilized automotive manufacturing expertise applied to aircraft requirements. The same precision machining, quality control, and assembly techniques that produced reliable car engines were adapted to produce reliable aircraft engines. German manufacturers struggled to achieve this cross-pollination between automotive and aviation industries. Americans think of manufacturing as manufacturing, Schmidt noted. It doesn't matter if you're making cars or tanks or airplanes. The principles are the same, the methods are the same, only the parts are different. This philosophical approach to manufacturing enabled rapid scaling and efficient resource utilization. American workers could transfer between different war production facilities with minimal retraining. German workers were specialized for specific industries and couldn't easily adapt to different production requirements. The human resource advantages compounded American industrial superiority in ways that Axis prisoners found difficult to accept. Friedrich Weber, after completing his shipyard assignment, worked at a Westinghouse electrical manufacturing plant where he encountered American industrial psychology that contradicted everything he had been taught about worker motivation. American workers, Weber observed, were not motivated primarily by fear or patriotic duty. They were motivated by personal economic advancement, social status, and individual achievement. This motivation produced higher productivity than the discipline-based system used in German factories. American workers work harder because they want to work harder, Weber wrote in a letter to his family. German workers work hard because they have to work hard. This makes a difference when you need people to work very hard for a long time. The sustainability of motivation proved crucial for long-term war production. German workers maintained high productivity through discipline and patriotic enthusiasm, but both factors declined as the war progressed and conditions deteriorated. American workers maintained productivity through personal incentives that remained strong regardless of military developments. American women's participation in war production particularly impressed Axis prisoners because none of their countries had successfully mobilized female labor on similar scales. Giuseppe Rossi worked alongside thousands of women at the Ford Willow Run plant, many of whom achieved higher productivity than the men they had replaced. In Italy, women don't work in factories, Rossi observed. In America, women work everywhere. They build airplanes, they drive trucks, they operate machines, they do everything men do, and often they do it better. The Rosie the Riveter phenomenon represented more than symbolic female empowerment. Women comprised approximately 35% of the American industrial workforce by 1944, providing labor resources that Germany and Japan couldn't match. German ideology restricted women's roles, while Japanese tradition limited female participation in heavy industry. This additional labor force allowed American industry to maintain both military production and essential civilian services. German industry struggled with labor shortages that forced the use of slave workers whose productivity and reliability were questionable. American industry operated with voluntary workers whose motivation and skills continuously improved. The training systems that prepared American workers for war production impressed Marco Bianchi during his assignment at the Consolidated Aircraft Plant in San Diego. Workers with no previous manufacturing experience were transformed into skilled aircraft assemblers through systematic training programs that German industry couldn't replicate. Americans teach workers like they teach children in school, Bianchi observed. Step by step, with books and pictures and practice, until everyone knows exactly what to do. German training relied on traditional apprenticeship systems that required years of experience to develop competency. American training used scientific instructional design that achieved competency in weeks or months. This rapid training capability enabled American industry to expand quickly without compromising quality. Moreover, American training was standardized across the industry, allowing workers to transfer between facilities without additional preparation. German training was facility-specific, creating labor immobility that reduced efficiency and limited flexibility. The technological advantages supporting American war production became evident to Antonio Ferrari during his assignment at the Lake City ammunition plant in Missouri. The facility utilized automated machinery, statistical quality control, and systematic process optimization that exceeded anything he had encountered in Italian or German industry. American ammunition production achieved quality levels and output rates through scientific management rather than traditional craftsmanship. Every aspect of the manufacturing process was measured, analyzed, and continuously improved based on statistical data. German ammunition production relied on skilled workers and traditional methods that couldn't achieve American levels of consistency or efficiency. Americans make bullets like they make everything else, Ferrari noted. With machines that think, workers who measure, and managers who count everything. This systematic approach to manufacturing eliminated the waste and inefficiency that plagued Axis production. German industry operated with tolerances and methods inherited from peacetime production. American industry was redesigned specifically for war production efficiency. The transportation systems supporting American war production provided logistical capabilities that Axis countries couldn't match under any circumstances. Hiroshi Tanaka's work at the Zenith facility in Chicago gave him access to American transportation networks that moved materials and finished goods with unprecedented efficiency. American railroads transported raw materials from sources to manufacturing facilities and finished goods from factories to military depots with scheduling precision that German railroads couldn't achieve even in peacetime. The American transportation system was designed for efficiency and capacity rather than the territorial control priorities that dominated German and Japanese transportation planning. Moreover, American transportation was protected from enemy interference by geographic isolation that Axis countries couldn't attack. German and Japanese transportation systems were vulnerable to Allied bombing, sabotage, and military interdiction. American transportation operated in complete security, allowing optimal efficiency without defensive considerations. The inland waterways system provided additional transportation capacity that European countries lacked. American manufacturers could ship bulky materials via rivers, canals, and lakes at costs below railroad transportation. This transportation advantage reduced manufacturing costs and enabled competitive pricing that supported expanded production. But the most significant advantage was the American highway system that connected manufacturing facilities with supply sources and distribution networks. American trucks could deliver materials door to door with flexibility that railroad transportation couldn't match. German industry relied primarily on railroads that were increasingly disrupted by Allied bombing. The consumer goods production that continued alongside American war production demonstrated economic capabilities that Axis prisoners found incomprehensible. Franz Richter, during his assignment at the General Motors tank plant, discovered that American industry was simultaneously producing military equipment and civilian goods at levels that exceeded German peacetime production. American civilian production during wartime included radios, appliances, clothing, and other goods that German civilians hadn't seen since 1939. This civilian production maintained morale and productivity while demonstrating industrial capacity that could easily support military requirements. Americans fight a war and live normally at the same time, Richter observed. We sacrifice everything to fight the war and still lose. The psychological impact of continued consumer goods availability supported American industrial productivity by maintaining worker satisfaction and social stability. German workers suffered increasing hardships that reduced productivity and undermined support for continued war effort. American consumer goods production also demonstrated manufacturing sophistication that military production statistics didn't fully reveal. The radios, appliances, and automobiles that Americans continued to purchase during wartime incorporated advanced materials, precision manufacturing, and quality control that exceeded military equipment produced by Axis countries. Werner Schmidt's assignment at the Ford aircraft engine facility exposed him to manufacturing techniques that transformed his understanding of industrial capability. American engine production utilized precision machining, metallurgical science, and quality testing that produced engines with reliability and performance characteristics beyond German achievements. American engines are not necessarily more powerful than German engines, Schmidt noted in his diary. But American engines work longer, need less maintenance, and cost less to manufacture. In war, these advantages matter more than maximum performance. The reliability advantage was particularly significant for sustained military operations. German equipment often achieved superior maximum performance but required constant maintenance and frequent replacement. American equipment achieved adequate performance with superior reliability and maintainability. This reliability difference multiplied American numerical advantages. German forces spent significant time maintaining equipment that should have been available for combat operations. American forces spent more time in operational status, effectively increasing the combat value of each unit. The maintenance systems supporting American military equipment impressed Friedrich Weber during his work at the Westinghouse electrical plant. American military equipment was designed for maintenance by relatively unskilled personnel using standard tools and procedures. German military equipment required skilled technicians using specialized tools and extensive training. Americans build machines for soldiers to fix, Weber observed. Germans build machines for engineers to fix. This design philosophy enabled American forces to maintain equipment readiness in field conditions where specialized maintenance facilities weren't available. German forces suffered declining equipment readiness as the war progressed and maintenance became increasingly difficult. American replacement parts production supported this maintenance advantage through standardized components that could be manufactured by multiple suppliers. German replacement parts were often facility-specific and couldn't be obtained when primary manufacturing was disrupted. The research and development systems supporting American war production provided continuous improvement that Axis countries couldn't match. Giuseppe Rossi's work at the Ford Willow Run plant exposed him to aircraft design modifications that were implemented without disrupting production schedules. American aircraft manufacturers received regular updates and improvements from research facilities, military testing organizations, and operational feedback systems. These improvements were incorporated into production through systematic modification procedures that maintained output while enhancing performance. German aircraft development involved complete redesigns that required production shutdowns and retooling delays. This development approach prevented continuous improvement and limited the incorporation of operational experience into manufacturing. Moreover, American research and development was supported by university cooperation that provided scientific expertise beyond industry capabilities. German research was fragmented among competing organizations that didn't share information effectively. The integration of scientific research with industrial production created synergistic advantages that accelerated both technological development and manufacturing efficiency. American manufacturers could implement scientific discoveries rapidly because research and production were systematically coordinated. Marco Bianchi's assignment at the Consolidated Aircraft Plant demonstrated American quality control methods that achieved consistency levels impossible with traditional inspection techniques. Every component was tested, every assembly was verified, and every aircraft was systematically examined before delivery. Americans don't just build airplanes, Bianchi noted. They prove that every airplane works before they send it to war. German quality control relied on skilled inspectors using traditional methods that couldn't examine every component or verify every system. This approach allowed defective equipment to reach combat units where failures could prove fatal. American statistical quality control identified problems before they caused failures, enabling preventive corrections that improved reliability and reduced waste. German quality control was reactive, addressing problems after they occurred rather than preventing them systematically. The training systems that prepared American military personnel to operate increasingly sophisticated equipment impressed Antonio Ferrari during his work at the Lake City ammunition plant. American military training was standardized, systematic, and efficient in ways that German military training couldn't match. Americans train soldiers like they train factory workers, Ferrari observed. With books, pictures, practice, and tests until everyone knows exactly what to do. German military training relied on traditional methods that required extensive time and experience to develop competency. American military training used instructional design principles that achieved competency rapidly and reliably. This training efficiency enabled American forces to utilize complex equipment effectively with personnel who had limited military experience. German forces required experienced personnel to operate sophisticated equipment effectively, creating personnel shortages that limited operational capability. The logistics systems supporting American military operations provided supply reliability that German and Japanese forces never achieved. Hiroshi Tanaka's work at the Zenith facility exposed him to American military supply networks that delivered equipment and materials with commercial efficiency. American military logistics operated like civilian commercial distribution, with systematic inventory management, reliable transportation, and efficient delivery procedures. German military logistics was ad hoc and improvisational, depending on local resources and improvised solutions. The American supply system could deliver specific parts, replacements, and materials to combat units anywhere in the world within predictable timeframes. German supply systems couldn't reliably deliver materials to units within Germany due to transportation disruptions and resource shortages. This logistics advantage enabled American forces to maintain equipment readiness and operational tempo that German forces couldn't match even under ideal conditions. American military operations were limited by strategic decisions rather than logistical constraints. But perhaps the most devastating realization for Axis prisoners was the casual attitude that Americans displayed toward their industrial achievements. Franz Richter's conversations with American workers revealed that they considered their war production accomplishments normal rather than exceptional. "We're just doing our jobs," explained Jake Morrison, a line supervisor at the General Motors tank plant where Richter worked. "Building tanks instead of cars isn't that different. Same people, same tools, same methods. Just different parts." This casual competence demonstrated industrial capability that was systematic rather than heroic. American war production was the natural result of industrial systems designed for efficiency and scalability. German war production required extraordinary efforts that couldn't be sustained indefinitely. American workers didn't consider themselves heroes for achieving production levels that German workers would have regarded as impossible. They considered exceptional productivity normal and continuously sought further improvements through systematic analysis and optimization. The post-war planning that American industry was already implementing by 1944 revealed confident expectations of victory that Axis prisoners found psychologically devastating. Werner Schmidt learned that American manufacturers were designing civilian products for post-war production while simultaneously achieving record military production. They planned to win the war and return to normal life, Schmidt observed. We plan to win the war or die trying. This difference in thinking changes everything. American industry expected to convert back to civilian production after victory, maintaining the same workers, facilities, and methods that had achieved wartime success. German industry had no realistic plans for post-war survival because victory was required to justify the sacrifices demanded by total war mobilization. This confidence in ultimate victory supported American industrial productivity by providing workers with positive expectations for the future. German workers faced increasingly desperate circumstances that undermined morale and productivity regardless of patriotic appeals. The financial systems supporting American war production demonstrated economic sophistication that Axis countries couldn't match. Friedrich Weber's work at the Westinghouse plant exposed him to American industrial financing that operated through voluntary investment rather than government compulsion. American war production was funded through war bonds purchased voluntarily by civilians who expected repayment with interest after the war. This voluntary financing maintained public support while providing industry with reliable funding for expansion and modernization. German war production was funded through taxation, confiscation, and slave labor that generated resistance and reduced efficiency. The German economy was unsustainable without continuous conquest to provide resources and markets. American financing was based on productive capacity and economic growth that would continue after the war. German financing was based on military conquest that would end with either victory or defeat, leaving no sustainable foundation for post-war economy. The educational systems that supported American industrial competency impressed Giuseppe Rossi during his assignment at the Ford Willow Run plant. American workers had educational backgrounds that prepared them for industrial employment in ways that European workers couldn't match. American public education emphasized practical skills, scientific literacy, and problem-solving abilities that transferred effectively to industrial applications. European education was primarily academic and classical, providing limited preparation for modern industrial requirements. Moreover, American continuing education systems enabled workers to acquire additional skills and advance their careers through systematic training programs. German workers were typically locked into educational tracks that limited their adaptability and mobility. This educational advantage enabled American industry to utilize workers more effectively and respond to changing requirements more flexibly. German industry suffered from skill shortages and training limitations that reduced productivity and prevented optimization. The communication systems that coordinated American war production achieved integration levels that German and Japanese systems couldn't match. Marco Bianchi's work at the Consolidated Aircraft plant demonstrated American industrial communication that operated with telephone efficiency and systematic coordination. American manufacturers maintained continuous communication with suppliers, customers, and government agencies through telephone, teletype, and radio networks that enabled rapid response to changing requirements and immediate correction of problems. German industrial communication was limited by security restrictions, transportation difficulties, and communication equipment shortages that prevented effective coordination between facilities and organizations. The communication advantage enabled American industry to operate as an integrated system where problems could be identified and resolved quickly. German industry operated as isolated facilities that couldn't coordinate effectively or share information systematically. Antonio Ferrari's work at the Lake City ammunition plant revealed American inventory management systems that maintained precise control over materials, components, and finished goods. Every item was tracked systematically from delivery through consumption or shipment. Americans count everything, Ferrari observed. Every bullet, every box, every pound of powder. Nothing gets lost, nothing gets forgotten. German inventory management was informal and approximate, relying on estimates and periodic physical inventories that couldn't track materials with American precision. This imprecision led to waste, shortages, and inefficient resource allocation. American inventory control enabled just-in-time delivery and minimum storage requirements that reduced costs and improved efficiency. German inventory control required large safety stocks and extensive storage facilities that tied up resources and created vulnerability to bombing attacks. The maintenance systems that kept American industrial equipment operating demonstrated preventive approaches that German industry hadn't adopted. Hiroshi Tanaka's work at the Zenith facility exposed him to systematic maintenance that prevented breakdowns rather than repairing them after they occurred. American industrial maintenance was scheduled, systematic, and predictive, utilizing statistical analysis to identify potential problems before they caused production disruptions. German industrial maintenance was reactive and emergency-oriented, addressing problems after they had already reduced productivity. This preventive maintenance enabled American facilities to maintain consistent production schedules with minimal downtime. German facilities suffered increasing breakdowns and production interruptions as equipment aged and maintenance became increasingly difficult due to parts shortages. The personnel management systems that motivated American industrial workers achieved productivity levels that German systems couldn't match through discipline alone. Franz Richter's work at the General Motors tank plant demonstrated American industrial psychology that utilized positive incentives rather than negative enforcement. American workers received performance bonuses, promotion opportunities, and recognition awards that motivated continuous improvement and high productivity. German workers were motivated primarily by discipline and patriotic duty that declined in effectiveness as conditions deteriorated. Moreover, American personnel management included systematic training, career development, and skill enhancement that increased worker value and satisfaction. German personnel management was primarily directive and controlling, providing limited opportunities for advancement or skill development. This positive approach to personnel management created sustainable motivation that maintained productivity throughout the war period. German approaches to personnel management were unsustainable under long-term pressure and declining conditions. Werner Schmidt's final assignment at a Ford facility producing military vehicles revealed American manufacturing integration that achieved efficiency through systematic coordination rather than heroic individual efforts. Every aspect of production was analyzed, measured, and continuously optimized through scientific management techniques. Americans don't work harder than Germans, Schmidt concluded in his diary. Americans work smarter than Germans. They think about work, they measure work, they improve work. We just work. This systematic approach to manufacturing enabled American industry to achieve continuous productivity improvements that compounded over time. German industry relied on fixed methods and traditional techniques that couldn't adapt to changing requirements or incorporate improvements systematically. The scientific management of American industry was based on objective analysis rather than traditional authority, enabling rapid identification and implementation of better methods. German industrial management was hierarchical and traditional, resistant to changes that challenged established procedures. Friedrich Weber's work at multiple American facilities during his 3 years as a prisoner of war provided perspective on American industrial integration that revealed systematic advantages beyond any single facility or production line. American industry operated as a coordinated network that multiplied individual advantages through systematic cooperation. Every American factory is connected to every other American factory, Weber observed in his final diary entry before repatriation. They share information, they share methods, they share workers, they share everything. German factories operate alone, even when they make the same products. This industrial integration enabled American manufacturers to achieve economies of scale, specialized efficiency, and rapid adaptation that isolated German facilities couldn't match. American industry was greater than the sum of its parts through systematic coordination and cooperation. The integration extended beyond manufacturing to include research, education, finance, transportation, and government policy in a coordinated system that supported industrial objectives. German industry operated in compartments that couldn't achieve similar coordination or mutual support. When the German prisoners were finally repatriated in 1946, many carried with them a fundamentally changed understanding of industrial capability and national power. Franz Richter returned to a Germany devastated by bombing, divided by occupation, and reduced to primitive conditions that contrasted starkly with the American abundance he had witnessed. "We never had a chance," he told his wife during their first private conversation in 3 years. "Not because German soldiers weren't brave or German weapons weren't good. We never had a chance because America is not a country that fights wars. America is a country that manufactures wars. And they manufacture wars better than we manufacture anything." The statistical evidence supported Richter's conclusion with overwhelming clarity. American industrial production during World War II had exceeded the combined production of Germany, Japan, and Italy by ratios that ranged from 3-to-1 to 10-to-1 depending on the category of equipment. But the numerical advantages were multiplied by systematic efficiencies that Axis countries couldn't match under any circumstances. Giuseppe Rossi, returning to an Italy partially rebuilt with American aid, carried similar revelations about industrial capability that transcended national boundaries. His work in American factories had revealed manufacturing principles and organizational methods that could be applied anywhere given adequate resources and systematic implementation. The Americans didn't win because they were Americans, Rossi wrote to his brother, who had served in the Italian Navy. The Americans won because they organized victory like a business and operated victory like a science. Any country could do the same things if they understood the same principles. But understanding the principles and implementing them were different challenges. European countries had centuries of traditional methods, established hierarchies, and cultural practices that resisted the systematic changes required for American-style industrial efficiency. American industrial success was based on cultural values that emphasized individual advancement, systematic improvement, and voluntary cooperation rather than traditional authority and established procedures. These cultural foundations couldn't be easily transplanted or rapidly adopted. Marco Bianchi returned to northern Italy with technical knowledge acquired during his work at American aircraft plants. But he found limited opportunities to apply American methods in Italian industry that was slowly rebuilding along traditional lines. "I know how to build airplanes like Americans build airplanes," Bianchi wrote in his memoir published in the 1950s. "But Italian factories are not American factories, Italian workers are not American workers, and Italian managers are not American managers. Knowledge is not enough when the system cannot use the knowledge." The systematic nature of American industrial advantages couldn't be duplicated through piecemeal adoption of specific techniques or technologies. American industrial success was based on integrated systems that required comprehensive coordination rather than individual improvements. European attempts to modernize industry along American lines achieved limited success because they couldn't replicate the cultural, educational, and organizational foundations that supported American industrial efficiency. Antonio Ferrari's post-war career as an industrial consultant in Italy provided additional perspective on the challenges of applying American methods in European contexts. His experience at American ammunition plants had taught him systematic approaches to manufacturing that Italian companies couldn't easily implement. American methods work in America because everything in America is designed to make American methods work, Ferrari explained to clients who sought to improve their manufacturing efficiency. To use American methods in Italy, you must change more than just the methods. You must change the workers, the managers, the suppliers, the customers, and the government. This is not improvement. This is revolution. The cultural changes required for American-style industrial efficiency were so fundamental that European countries chose different approaches to post-war reconstruction that utilized traditional strengths rather than attempting to duplicate American methods. German industrial reconstruction, supervised by American occupation authorities, incorporated some American techniques but retained distinctly German characteristics that emphasized engineering excellence and craft expertise rather than mass production efficiency. Hiroshi Tanaka's return to Japan provided the most dramatic contrast between American industrial capability and traditional methods. Japan in 1946 was devastated by bombing, blockade, and military defeat that had reduced the country to pre-industrial conditions. Tanaka's experience at American electronics plants had taught him manufacturing techniques that Japanese industry wouldn't achieve for another decade, but his knowledge was essentially useless in a country that lacked the basic infrastructure required for modern industrial production. "I learned the future in America," Tanaka wrote in his diary after returning to Japan. But Japan must first rebuild the past before it can implement the future. Japanese industrial reconstruction followed a different path that combined American techniques with Japanese organizational methods, eventually achieving efficiency levels that exceeded American achievements in specific industries. But this success required 20 years of systematic development that built upon traditional Japanese strengths rather than simply copying American methods. The prisoners of war who had witnessed American industrial capability firsthand became important sources of information for post-war reconstruction efforts, but their knowledge was most valuable for understanding American strengths rather than directly implementing American methods. Werner Schmidt's post-war career as a technical consultant for German automotive companies utilized his knowledge of American manufacturing to develop German approaches that achieved similar efficiency through different methods that were compatible with German industrial culture. The Americans showed us what was possible, Schmidt explained to German industrialists seeking to modernize their facilities. But we must achieve the possible in German ways, not American ways. The goal is efficiency, not imitation. This approach to industrial modernization proved more successful than direct attempts to copy American methods because it utilized existing strengths while addressing recognized weaknesses through systematic improvement rather than comprehensive replacement. The long-term impact of prisoner of war exposure to American industrial capability extended beyond individual knowledge to influence European and Japanese approaches to economic development that emphasize different paths to industrial efficiency rather than direct competition with American methods. Friedrich Weber's post-war work with German shipbuilding companies incorporated lessons learned from American shipyards, but the applications were specifically adapted to German conditions and capabilities rather than attempting to duplicate American approaches. American shipbuilding taught me the importance of systematic methods, Weber explained in a technical presentation to German shipbuilders in the 1950s. But German shipbuilding must use German systematic methods that work with German workers, German materials, and German markets. This adaptive approach to industrial improvement proved more sustainable than attempts to transplant American methods directly because it built upon existing capabilities while incorporating proven principles of efficiency and quality control. The prisoner of war experience had provided invaluable education in industrial capability, but the most important lesson was understanding the systematic nature of American advantages rather than the specific techniques that produced those advantages. The post-war economic development of Germany, Italy, and Japan incorporated many principles observed by prisoners of war in American facilities, but the implementations were uniquely suited to each country's conditions and capabilities rather than simple imitations of American methods. Franz Richter's final reflection on his prisoner of war experience, written in a memoir published in the 1970s, summarized the fundamental lesson that had taken him 30 years to fully understand. We lost the war when we started the war, but we didn't know this because we didn't understand what we were fighting against. We thought we were fighting America, the country. We were actually fighting America, the industrial system. Countries can be defeated by superior force. Industrial systems can only be defeated by superior industrial systems. We never had a superior industrial system. We never even had an equivalent industrial system. We had traditional methods fighting systematic methods, individual excellence fighting organized efficiency, and craft production fighting mass production. The outcome was determined before the first shot was fired. The statistical evidence that supported Richter's conclusion was overwhelming and undeniable. American war production from 1941 to 1945 had totaled approximately $300 billion in 1945 currency values, representing approximately 40% of global industrial output during those years. German war production during the same period totaled approximately $60 billion, while Japanese war production totaled approximately $20 billion. Italy's industrial contribution was negligible after 1943. The combined Axis industrial capacity was less than one-third of American industrial capacity. But raw production statistics understated the true disparity because American production was sustainable while Axis production was based on unsustainable expedients that became increasingly desperate as the war progressed. American production was based on voluntary labor, domestic resources, and systematic efficiency that could continue indefinitely without external support. Axis production was based on slave labor, conquered resources, and extraordinary efforts that required continuous military success to maintain. The sustainability difference meant that American industrial advantages increased over time while Axis advantages decreased over time, creating compound disparities that made eventual Axis defeat mathematically certain regardless of military developments. Giuseppe Rossi's analysis of the industrial fundamentals, published in an Italian economics journal in the 1960s, provided additional perspective on the systematic nature of American advantages that made Axis defeat inevitable. The war was not decided by battles, strategies, or weapons. The war was decided by industrial capacity, and industrial capacity was decided by systematic organization, voluntary cooperation, and scientific management. These advantages were not military secrets that could be stolen or discovered. These advantages were cultural achievements that required generations to develop and could not be duplicated through imitation or compulsion. The cultural foundations of American industrial success were based on values and institutions that had evolved over more than a century of industrial development. European and Japanese attempts to achieve similar results were handicapped by cultural and institutional legacies that were incompatible with the systematic cooperation required for maximum efficiency. American industrial culture emphasized individual advancement through collective success, creating motivation for workers to contribute their best efforts toward organizational objectives. European industrial culture was based on class distinctions and traditional hierarchies that limited cooperation and reduced efficiency. American educational systems prepared workers for industrial employment through practical training and scientific literacy that enabled them to contribute effectively to systematic improvement efforts. European educational systems were primarily academic and classical, providing limited preparation for industrial requirements. American financial systems supported industrial development through voluntary investment that aligned private interests with national objectives. European financial systems were controlled by traditional elites whose interests were not necessarily aligned with industrial efficiency. The systematic nature of these advantages meant that American industrial superiority was not accidental or temporary but was the predictable result of cultural and institutional developments that had been evolving for decades before the war began. Marco Bianchi's final assessment, written shortly before his death in the 1980s, summarized the long-term implications of prisoner-of-war observations of American industrial capability. We learned that industrial wars are not won by the countries with the best soldiers or the most sophisticated weapons. Industrial wars are won by the countries with the most efficient systems for converting resources into military capability. American efficiency was not superior because Americans were superior people. American efficiency was superior because American systems were superior systems. The difference was systematic, not individual. This systematic understanding of industrial warfare influenced post-war strategic thinking in ways that extended far beyond the specific experiences of individual prisoners of war. The recognition that systematic advantages were more important than individual advantages changed how military planners evaluated national capabilities and strategic options. The Cold War competition between the United States and Soviet Union was fundamentally a competition between different systematic approaches to industrial organization rather than a competition between specific weapons or military technologies. European and Japanese economic development during the post-war period reflected lessons learned about systematic organization that had been observed by prisoners of war in American facilities. The emphasis on systematic improvement, scientific management, and organized cooperation became characteristics of successful post-war economies, regardless of their specific political or cultural contexts. Antonio Ferrari's contribution to Italian industrial development during the 1950s and 60s incorporated systematic approaches to manufacturing that had been learned through prisoner-of-war experience in American facilities. But the applications were specifically adapted to Italian conditions rather than direct imitations of American methods. The Americans taught us the importance of systems, Ferrari explained in a speech to Italian industrialists in 1960. But each country must develop its own systems that work with its own people, its own resources, and its own circumstances. The principle is universal, but the applications must be specific. This approach to systematic industrial development proved successful because it incorporated proven principles while respecting cultural and institutional differences that required different implementations of similar concepts. The long-term legacy of prisoner of war exposure to American industrial methods was not the direct transplantation of American techniques, but the recognition that systematic organization was more important than individual brilliance for achieving sustained success in industrial competition. Hiroshi Tanaka's influence on Japanese industrial development during the post-war period reflected this understanding of systematic principles that could be implemented through Japanese methods rather than American methods. His experience at American electronics plants had taught him the importance of systematic quality control, continuous improvement, and organized cooperation. Japanese implementations of these principles eventually achieved efficiency levels that exceeded American achievements in specific industries, but the success was based on Japanese systematic approaches rather than copied American techniques. Americans showed us that systematic organization could achieve results that individual excellence could not match, Tanaka explained in a presentation to Japanese engineers in the 1970s. But systematic organization must be implemented through methods that are compatible with the people who must operate the system. Japanese systematic organization must be Japanese, not American. This understanding of systematic principles led to Japanese industrial methods that incorporated American insights while utilizing Japanese cultural strengths, such as group loyalty, attention to detail, and commitment to continuous improvement. The ultimate irony of prisoner of war education in American industrial methods was that the most successful applications occurred when the principles were adapted to different cultural contexts rather than when the methods were directly copied. Werner Schmidt's influence on German automotive industry development during the post-war period demonstrated how systematic approaches could be implemented through traditional German strengths in engineering excellence and precision manufacturing. The Americans taught us that mass production could achieve quality through systematic methods rather than individual craftsmanship, Schmidt explained to German automotive executives in the 1960s. But German mass production must utilize German systematic methods that build upon our traditional strengths rather than replacing them. German automotive success during the post-war period was based on this synthesis of American systematic principles with German engineering traditions that created unique approaches to industrial efficiency. The prisoner of war experience had provided education in systematic thinking that proved more valuable than education in specific techniques because systematic thinking could be applied to any industrial challenge while specific techniques were limited to particular applications. Friedrich Weber's post-war career in German shipbuilding demonstrated how systematic approaches to industrial organization could revitalize traditional industries through improved methods rather than complete replacement of existing capabilities. American shipbuilding taught us that systematic organization was more important than individual skill for achieving consistent results, Weber explained in a technical paper published in the 1970s. But systematic organization can be applied to any approach to shipbuilding, including approaches that emphasize individual skill and traditional craftsmanship. This understanding enabled German shipbuilding to achieve competitive efficiency through systematic applications of traditional strengths rather than attempting to compete directly with American mass production methods. The lasting impact of prisoner of war exposure to American industrial capability was the recognition that systematic organization was a universal principle that could be implemented through various methods rather than a specifically American approach that could only be duplicated through imitation. Franz Richter's final interview, conducted shortly before his death in the 1990s, reflected on 50 years of thinking about the industrial lessons learned during his prisoner of war experience. The most important thing I learned in America was not how Americans did things. The most important thing I learned was why Americans did things the way they did them. The why was systematic thinking that could be applied anywhere. The how was American methods that worked in America. Understanding the difference took me many years, but understanding the difference was more valuable than learning the methods. This distinction between systematic principles and specific methods provided the foundation for successful post-war industrial development that incorporated American insights without attempting to duplicate American conditions. The prisoner of war experience had provided a unique education in industrial capability that influenced European and Japanese development for decades after the war ended. But the most valuable lessons were not the specific techniques observed in American facilities but the systematic thinking that made American techniques effective. The recognition that systematic organization was more important than individual excellence, that voluntary cooperation was more efficient than compulsory coordination, and that scientific management was more reliable than traditional authority provided principles that could be applied in any cultural context through appropriate methods. These principles became the foundation for post-war economic development that achieved industrial efficiency through systematic approaches that were specifically adapted to different cultural and institutional contexts rather than attempting to duplicate American conditions. The ultimate legacy of prisoner-of-war education in American industrial methods was not the spread of American techniques, but the spread of systematic thinking that enabled each country to develop its own approaches to industrial efficiency based on proven principles rather than traditional assumptions. The war had been lost by the Axis powers before it began because they had failed to understand the systematic nature of industrial competition in the modern era. But the prisoner-of-war experience had provided education that enabled post-war reconstruction based on systematic approaches that prevented future industrial disadvantages from becoming as decisive as they had been during World War II. Giuseppe Rossi's final reflection, written in the 1980s, summarized the long-term significance of prisoner-of-war education in American industrial capability. We went to America as prisoners and returned as students. We lost the war but gained an education. The education was worth more than the war because the education enabled our countries to build industrial capabilities that made future wars unnecessary. Understanding American methods was valuable, but understanding systematic thinking was invaluable. The systematic thinking that had made American industrial success possible became the foundation for post-war economic development that transformed Europe and Japan from defeated enemies into successful allies whose industrial capabilities eventually rivaled American achievements through different methods based on the same systematic principles. The prisoner-of-war experience had provided education that was more valuable than military victory because it enabled understanding of industrial principles that could be applied indefinitely rather than military techniques that were useful only during wartime. The ultimate irony was that defeat in war had provided educational opportunities that victory might not have offered, and the education had proven more valuable for long-term national development than military success would have been. When Franz Richter, Werner Schmidt, Friedrich Weber, Klaus Hartmann, Giuseppe Rossi, Marco Bianchi, Antonio Ferrari, and Hiroshi Tanaka first set foot on American soil as prisoners of war, they had expected to find a wealthy country that had been protected by geography from the devastation of modern warfare. What they found instead was an industrial civilization that had systematized efficiency, organized cooperation, and scientifically managed production in ways that made their own country's industrial efforts appear primitive by comparison. They had realized, as Franz Richter had first understood watching the endless parade of ships in New York Harbor, that they never had a chance not because American soldiers were better fighters or American weapons were superior machines, but because America had developed systematic approaches to converting resources into military capability that could not be matched by traditional methods, individual excellence, or desperate expedients. The war had been decided by industrial capacity, and industrial capacity had been decided by systematic organization that required generations to develop and could not be duplicated through imitation or compulsion. The recognition of this reality was devastating for morale but invaluable for education. The prisoner-of-war experience had transformed defeat in war into victory in understanding, and understanding had proven more valuable than military success because it provided the foundation for post-war development that made future industrial disadvantages avoidable. They never had a chance to win the war, but they had gained the chance to understand why, and understanding why had made possible the systematic approaches to post-war development that eventually enabled their countries to achieve industrial capabilities that made future wars unnecessary. The education had been worth more than victory because education was permanent while victory was temporary. The systematic thinking they had learned by observing American industrial methods had become the foundation for post-war economic development that transformed defeat into long-term success. In the end, they had lost a war but gained an understanding that was more valuable than military victory because it enabled systematic approaches to national development that made future defeats avoidable and future successes achievable through systematic methods rather than heroic efforts. The ultimate lesson of their prisoner-of-war experience was that systematic thinking was more powerful than individual brilliance. Organized cooperation was more efficient than compulsory coordination, and scientific management was more reliable than traditional authority. These principles could be applied anywhere through appropriate methods, making defeat in one context the foundation for success in another context. They never had a chance to win World War II, but they had gained the chance to understand industrial competition in ways that made future success possible through systematic approaches that built upon their traditional strengths while incorporating proven principles of efficiency and organization. The war was over, but the education was permanent, and the education had proven more valuable than the war because it enabled understanding that could be applied indefinitely rather than military techniques that were useful only during wartime. When the last of the repatriated prisoners of war finally returned home to countries that had been transformed by defeat into opportunities for reconstruction, they carried with them an understanding of systematic industrial organization that became the foundation for post-war development that eventually enabled their countries to achieve industrial capabilities that rivaled their former enemies through different methods based on the same systematic principles. They had learned that they never had a chance to win the war, but they had gained the chance to win the peace through systematic approaches to national development that made military competition unnecessary because industrial cooperation was more profitable than industrial conflict. The prisoner of war experience had provided the education that transformed military defeat into economic victory through systematic thinking that proved more valuable than military success because it was permanent, transferable, and applicable to any challenge requiring organized cooperation and systematic improvement. In the end, they had lost everything and gained everything, because losing the war had enabled gaining the understanding that made future wars unnecessary and future success achievable through systematic methods that could be applied anywhere by anyone willing to learn systematic thinking rather than simply copying specific techniques. The war had ended with their defeat, but their education was just beginning, and the education would prove more valuable than military victory because it enabled systematic approaches to national development that transformed former enemies into future allies whose industrial cooperation was more beneficial than industrial competition had ever been. They never had a chance to win World War II because they had not understood systematic industrial organization, but they had gained the chance to win the future because prisoner of war experience had provided education in systematic thinking that could be applied to any challenge requiring organized cooperation and scientific management. The ultimate irony was that defeat had provided opportunities for education that victory might have prevented, and the education had proven more valuable than victory because it enabled systematic approaches to development that made future defeats unnecessary and future successes inevitable through systematic methods rather than heroic efforts or fortunate circumstances. When they first realized they never had a chance, it was devastating. When they finally understood why they never had a chance, it was liberating, because understanding enabled systematic approaches to future challenges that made success achievable through organized effort rather than dependent on luck, genius, or circumstances beyond their control. The war was history, but the education was the future, and the future had proven more valuable than the past because it enabled systematic approaches to development that could be applied anywhere, anytime, by anyone willing to learn systematic thinking rather than simply repeat traditional methods or copy successful techniques. In the final analysis, they had learned that they never had a chance to win the war, but they had gained every chance to win the peace through systematic approaches to national development that transformed military defeat into educational victory, and educational victory into economic success that was more valuable than military victory because it was permanent, sustainable, and transferable to future generations who would benefit from systematic thinking long after the war had been forgotten.